Hello everyone, I hope you guys are doing good and staying safe. Welcome to SimpliCode's YouTube channel, and in today's session, we'll understand how to perform traversal and searching operation in Doubly Linked List. Now, in a previous session, we discussed how to perform insertion and deletion in Doubly Linked List at various positions, like at the beginning, at a specific node, and at the end of the linked list. So, traversal and searching are also another important operation in data structure, which is a critical operation, you can say, that can be performed on any data structure. So traversing means going through each element one by one, and so you can say it is a process of accessing every element in a linked list or in general of any data structure. So accessing a data structure element means visiting each and every element at least once, and this can be done in both forward and backward ways. So traversing is done to display every element of a data structure or to perform any operation on the linked list. So we will try to understand how to perform this traversal and searching operation in Doubly Linked List. So without any further ado, let's get started. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel SimpliCode to stay updated with all the latest tech content. And hit that bell icon to never miss an update from us. So alright, as you can see, Visual Studio Code has started. So firstly, let us run the code to perform traversal in Doubly Linked List. Alright. So now to traverse a doubly linked list using any language, so we are using C++ here, you can start at either the head or tail of the list and then follow the previous or the next pointers to visit each node in the list. So let's just understand how it is implemented. So include the header files first, hash include iostream, and using namespace std. Now we have to define the structure for the doubly linked list. So I'm taking a structure node, and inside that I am initializing the data which will store the value into the node, and then we are creating pointers to the previous and the next. So node asterisk previous, which is one pointer, and another pointer node asterisk to the next. Alright, so next let us create a function to traverse the doubly linked list in a forward way. So let's just take a function, let's say void traverse forward, let the function name be, and inside that we'll pass some arguments, which is node asterisk head. So firstly, the element that will point will be to the head node. So the current node what I'm taking is pointing to the head. So node asterisk current is equals to head. Alright. So next we have to traverse this linked list until the end, so that each and every element will be accessed at least once until the end of the list is reached. So we have to write a loop here. So while current is not equals to the null pointer. Now we know the null pointer is at the end of the list, right? So until it is not reaching the end of the list, so we will basically print this data. So cout current data, current of data will be printed, and we will store this value in the current as well. So current is equal, once it is saved, the current value will be updated and it will point to the current of the next value, and then cout. Cout end line, come back. So I hope you understood this. We're just defining a node structure to represent a node in the doubly linked list. Then the node structure has a data field int data to show the value of the node, and we have previous and next fields to point to the previous and next nodes in the list respectively. We are then defining function which is a traverse forward to insert nodes at the beginning. So in the main function, again we will call this value at the end. So what is happening in this is, in this example, the traverse forward function it takes the head of the doubly linked list as a parameter and then initializes a pointer current to the head over here. So it then enters a loop. So we are creating a loop while which iterates until the current reaches the end of the list. That is until the current becomes the null pointer. Now during each iteration of the loop, the function prints out the data of the current node using the cout current of data. And then it will systematically update the current to point to the next node in the list using current of current next. So next, let us write a function to traverse the doubly linked list in the backward way. All right. So let's just take another function, void traverse backward. All right. So it will start from the back. So we need to pass a parameter which is tail here. So node asterisk tail will be the parameter that will be passed inside the function, and we are assigning the value to this. The node of current is being assigned to this tail value. So the node asterisk current is equals to tail. So again we have to traverse until it is reaching from end to the beginning of the list. So again we have to write a while condition, which is while current is not equals to the null pointer, null ptr, we have to print that data, which is current of data. All right, and we have to show that value. So current is equals to current of previous, and again cout end line. Alright, so we have successfully created two functions for forward traversal and backward traversal here. Now let's just write a function to insert a node at the beginning of the doubly linked list. So for that I'm taking another function. Let's take void insert beginning. So you can take the name of your function as per your choice. I'm just taking a name, void insert beginning. So inside that I am passing parameters, node of head, comma node asterisk tail, and the data that will be stored in our doubly linked list, int data. So if you understood the parameters, now you must have got to know what will be passing and the idea behind inserting the elements at the beginning of the linked list. So what we'll do is node asterisk new node is equals to new node. So we are just assigning the value to the new node here. Now the new node of the data will point to the data, right? So the new node will point, the new node of data is equals to data. Now if you are inserting at the beginning, the new node of the previous node will point to the null value, the null in the node. So for that, new node of previous point to the null value. In the semicolons, otherwise it will throw an error. And the new node of the next will point to the head of that node, is equals to head of that node. Alright. Also we have to check if the list is empty, then we have to set the tail to the new node, right? So we are just checking if head is empty or not. So if head is equals to null pointer, so we are just basically checking if the list is empty, then tail will be equals to the new node. Else, give the else condition, head of previous will become the new node. Head of previous will become the new node here. And then we have to assign the head to the new node. Head is equals to new node. Alright. So we have inserted a function to insert some values at the beginning of the node. Now similarly, we will write a function to insert a node at the end of the doubly linked list. So take another function, void insert at let's take insert at end. So again pass the values, node of head, comma node asterisk tail, comma int data. So the node asterisk of new node is equals to new node. Now the new node of data will point to the data that is being added into the end of the linked list, and new node of previous will become tail. Sorry, new node of previous is becoming tail, comma new node of next will point to the null pointer equals to null pointer. So again we are checking if the list is empty, and we will set the head to the new node if the list is found empty. So if tail is equals to null pointer, then head is equals to new node, else tail of next will become the new node. And we have to save this value into the tail. So tail will become the new node here. So I hope you've understood this. We have created another function to insert values into the end of the doubly linked list here. Now we are left with the main function where we'll just call all these parameters and insert some values. So I'm creating a main function. So initializing the node asterisk head to the null pointer, and similarly node of tail as well to the null pointer, to the null pointer. Now we will insert some nodes at the into the doubly linked list. Firstly insert at, let's take it end. So head, passing the parameters of head and tail, head comma tail comma, let's take 1. Similarly insert at end, head comma tail is equals to 2. So insert at end, again we are inserting another value, head comma tail comma 3. So also we'll insert some values at beginning as well. Insert beginning is the function which you have taken, right? So insert beginning, head comma tail comma 0. So next let us try to traverse the doubly linked list in the forward way. So we have taken function traverse forward, and inside that we'll call the head value. Similarly, let us try to traverse the doubly linked list in the backward way also. So traverse backward. Now since we are traversing from the backward, we need to specify the tail. Alright, and return 0. So this is the code in order to implement traversal in doubly linked list in both forward and backward manner. So let's just try to execute this and see the output. So it will take some time to execute. So let's just wait and we'll see the output. So as you can see that the output is 0, 1, 2, 3 and 3, 2, 1, 0. So this is the forward traversal where it is searching each and every element in the doubly linked list, which is 0, 1, 2, 3, and then it is also performing a traversal in reverse direction, which is 3, 2, 1, 0. So in this way you can perform traversal in doubly linked list, and I hope you've understood this. So next let us now move ahead and discuss how to search a particular element in a doubly linked list. So for that, let me just take another file over here. So let us now try to implement this. So include the header files again. Using namespace std. Okay, let's just comment this what you're trying to do here. So we are basically performing a search operation. Now search operation basically in simple words is to basically find a particular element that you want to retrieve from a particular index in a doubly linked list. So searching an element in doubly linked list, in short DLL. Okay. So again we have to define a node structure. So I am defining struct node and initializing the data that will show the value within the node, and then the 2 pointers which are node of next, pointer to the next node and pointer to the previous node. So let's next create a class doubly linked list, and inside the class we will pass the members of this class into our function. So doubly linked list will be the class, and inside that I'm creating a private class, private member function, node of head, a public member function, and I'm using a constructor to initialize the doubly linked list to null value. So doubly linked list is a constructor which we will set it to be null. So head will be equals to null at the beginning while we create a empty linked list. Alright, I hope you understood this. So next let us try to add some new elements into our linked list. So firstly let us insert some elements at the end of the list. So I am taking a function void insert, and int, I am taking a parameter int new element since we are trying to add a new element. So again the algorithm or the code would be again similar. Node of new node will be set to the new node, and the new node of data will point to the new element that we are inserting, right? So new of data is equals to new element, and the new node of next will become the null value, similarly new node of previous will point to the null as well. Right, so also we have to check if head is equals to null, which is another case. If head is equals to null, then head will become the new node. Alright, and we have to mention the else statement as well, where node asterisk temp, I'm taking a temporary variable which is equals to head. Now while this temp of next is not equals to null, okay, then temp is equals to temp of next. Alright, and we will save this value temp of next into the new node as well. So temp of next is equals to new node. Now this new node of previous will take the temporary value is equals to temp. So I hope you understood till now, where we are just inserting values into our doubly linked list over here. Now next we have to create a function in order to search an element in the list, right? So for that, let's take a function void search element as our function name, and we will pass a value int search value. Okay, so firstly node of temp will be node asterisk temp will be equals to head. So I'm initializing int let's take found equals to 0 initially. Next int I is equals to 0. For that would be if the temporary pointer which you have taken is equals to if temp is not equals to null, and while temp is not equals to null, we will increment the value, that is I plus plus. So if temp of data is equals to the value that we are searching for, so is equals to the search value, then we will say found plus plus, and we will break the loop. Alright, and we will store the value in the temp. So temp is equals to temp of next. Again, if found is equals to 1, then we'll print the values accordingly. So in that case, we will see out search value is a parameter that we are passing again. So we will say that is the value is found at node, which is equals to the value that is I. So put a semicolon, and else we'll pass the search value, which is out search value is not found. So if you're trying to find the value which is equals to found is equals to 1, then it will print us the value is found at a particular node. Otherwise, it will not found the node at that particular position. So we'll just write search value is not found. Is not found, let's say, in the list. So end the line. Again, if it doesn't find anywhere in the list, we will say that the list is empty. So again, an else function out the list is empty. All right. So once we're done with this, we have to display the values in our linked list, right? So we'll just create another function void print list in order to display the contents that are present in our doubly linked list. So for that, again, I'm taking node asterisk head is temp is equals to head. So if temp is equals to null, if temp is not equals to null, cout, we will say that the values that are present in this list would be. So I'm just taking the list contains those certain values. Now while temp is not equals to null, then cout temp of next becomes the data. Temp of the data is the one which we are trying to pass. So it becomes temp is equals to temp of next. And once we're done with this, we will finish the end line, cout end line, or else we will say that the list is empty. Cout list is empty. So we're done with this. Now we're just left with the main function here. So let's just pass that. Int main, and I am taking a variable. Let's say we are passing the function which we have taken earlier, which is Doubly Linked List. I am creating a member function for this, which is DLL as our name. So we'll just add some elements at the end of the list. So DLL dot insert is the function which you have taken. So I am taking 30. Sorry, let's take in a continuous manner 10. DLL dot insert 20. DLL dot insert 30. And then we'll traverse the list to display the content. So DLL dot print list. Next, we will try to search for some elements in our list. So DLL dot search element is the function. So I'm just passing here. And again, search element. Let us see it was at what position the element 10 is present. Next, we will also search for another element which is not there in the list, and we will see what the output will be. So search element, let's take 15. Since we do not have 15 in our linked list, it will throw an error saying that 15 is not present in the list. And finally, we will search the third element. Alright, and then we will return the value. So it is return 0 and close the bracket. So this is the code in order to search an element in a doubly linked list. So let's just execute this and we'll see the output. So as you can see, it says that the list contains 20, 30 as the elements. Now 10 is found at the node 1. So it is saying 15 is not found in the list since we have 10, 20, 30 as the elements. Next, 20 is found at the node 2 at the second position. So in this way, we can perform searching and traversal operations in Doubly Linked List. I hope you understood this. Thank you for watching the video, guys. If you found this tutorial informative and helpful, give it a thumbs up and share it with your friends and colleagues. If you have any further queries regarding any of the topics covered in today's session, feel free to let us know in the comment section below, and a team of experts will be more than happy to help resolve all your queries at the earliest. Until next time, stay safe, thank you, and keep coding.